This is a presentation related to a peer graded assignment for Coursera project, which is known as Managing Machine Learning Projects. The objective of which is to identify a project topic and then work through a series of steps to evaluate the opportunity and walk through the business understanding through CRISP-DM process, and later develop a validation plan and ML architecture system in order to implement the same. For the purpose, I have included a project topic related to a combined cycle power plant, for which we have a data set of approximately 9,000 records. We have four input parameters and one target variable. The four input parameters are temperature, ambient pressure, relative humidity, and exhaust vacuum. So these are the variables, input variables, which play a direct or indirect role to identify the net hourly electrical energy output, which is basically our target variable. So, okay, uh, first of all, we'll do the opportunity evaluation. So for this particular project, I think ML is a very suitable solution, because if, let's say, some user want to predict uh, uh, energy output for a power plant with the given input features, machine learning solution is a good solution because of 3 factors: predictability, availability of data, and business impact. Predictability is because we know that the relationship between environment factors and energy output can be complex, and because of this, machine learning models are valuable to identify the hidden patterns. We have ample uh, data records in order to test and train the predictive model. The business impact is also very useful, because with the help of this model, we'll be able to serve users who want to predict the energy output for a power plant. Now, moving towards the CRISP DM business understanding, uh, the defining success parameter would be reducing in the forecasting error. So users will be forecasting the energy output, so we'll be uh, minimizing that error as uh, possible as we can. So we have these input features and the target variable. Our stakeholder will be the end users who will be using our platform in order to find out the energy output. Uh, the benefits will be improved power output prediction, which will lead to a better resource allocation and, of course, cost savings. The validation plan. So, for the validation, we'll be conducting interviews with the power plant operators to understand their needs and existing forecasting methods. Also, we'll be validating the usefulness of predictions through the historical data comparisons with them. We'll be using 80% of data to train the model and 20% to validate the model. So, for the purpose, we'll try to use multivariate linear regression model, and of course, we'll be validating that as well, that if the particular algorithm works or not. And we'll be using RMSE, MAE, MAPE, and R squared as an evaluation metrics. There is also ML system design, so there can be multiple algorithms which we can use for this purpose. We'll also have to look into data pipeline and deployment strategy. So just for the sake of proof of concept, we'll be creating a model here itself, where we'll be uh, creating a model and finally evaluating our model with the help of matrices. So we uh, over here, as you can see, first of all, we are trying to look into the data set and find out if the input features have linear relationship with the output variable or not. As we can see, we have tried to find out the linear relationship for each of the four input features with the output variable, and somehow they are likely the first two variables are very linear, very linearly uh, related to each other, and the last one is kind of very less relative with respect to if they are linear or not. And at the end, our output metrics say that uh, by we have evaluated and we saw that our model is working fine. um, the RMSE which we have found was 4.8. uh, MAE turned out to be 3.8, and MAPE 0.844. R squared turned out to be 0.91919, which is kind of pretty good. So we'll be moving forward with this particular solution, where we made the model with the help of multivariate linear regression model. So now coming to the last point, where, in order to identify the potential risk in production. So there can be model drift concerns, where we have to see if environmental conditions and plant performance may change over time, and of course that can affect the model accuracy. So we'll have to keep maintaining this particular model and keep changing as per the requirements. uh, the mitigation strategy would be, of course, as I mentioned, regular model retraining and continuous monitoring of prediction and errors. So other risk can be system latency. Predictions should be made in near real time to be useful for plant operators, and interpretability to ensure explainability so operators can trust and act on the predictions.